Hello guys, this is your lesson for today. So the first thing we're going to talk about is L'Hopital's rule. It's a rule for limits, but you can't teach it in the limits unit because you need to know your derivative rules in order to do it. So that's why it fits in this unit where we're doing all the derivative rules. The two indeterminate forms that you're going to notice when you're going to use L'Hopital's rule is if you get 0/0, which we've talked about before, or infinity over infinity. There are actually a ton of other indeterminate forms like 0 to the infinity power, or infinity times infinity, or infinity to the 0 power, which you are welcome to Google. These are the only two that we're going to do, but there is a lot of weird stuff that can happen. So here's what L'Hopital's rule says. Limit as x goes to c. And again, when you do an actual problem, that will be a number. So like limit as x goes to 7 or whatever. Of f of x over g of x. Don't get hung up on them being called f and g, just the one on the numerator and the one on the denominator. If that comes out to one of these two indeterminate forms, and only if it comes out to one of these two indeterminate forms, you can rewrite it as limit as x goes to c of f prime over g prime. So you can take the derivatives. You take the derivatives separately. It's not a quotient rule. Now, this is only if f of x and g of x are differentiable, which should make sense. If you have to be able to take a derivative, you can't do that if it's not differentiable. Now, when you see this on the free response, and notice I said when you see this on the free response, they like always throw one of these on there. You have to actually write quite a lot to justify using L'Hopital's rule, which is pretty annoying because it's a very simple thing to do, but they make you write a whole bunch of extra stuff. It's not hard, but you have to do it. So since 0/0 and infinity over infinity aren't a number, they aren't values, you can't say that anything equals them. Can't equal something to 0/0 or infinity over infinity because they technically don't exist. They're not real. So what you have to do is do these limits separately. So I'm going to write limit as x goes to 1 of just the numerator. And I'm going to write limit as x goes to 1 of just the denominator. I'm only going to make you do this for the first one. After this, for all the other examples, we'll just do it the quick way. We'll pretend those are like multiple choice questions. If it's free response, you have to write it like this. So if you plug in 1 to this, you get 1 minus 4 plus 3. That comes out to 0. If you plug in 1 here, you get 1 plus 3 minus 4, which comes out to 0. This is how you show that it comes out to one of these two forms, but you have to do them separately because, again, 0/0 is not a thing. So you have to do them separately. Then you also have to say x squared minus 4x plus 3 and x squared plus 3x minus 4 are differentiable. So you show that it comes out to this indeterminate form. You write that both of the functions are differentiable. Then, and only then, are you allowed to actually link these together. So we're going to write the problem. I know you're like, oh my gosh, we really have to write all this. I'm sorry, I'm the messenger. I don't really agree with this either, but I'm telling you, this is how you get all the points on the AP exam. And it's not hard. It's just a lot of writing. Hey, Ms. Cole, it looks like you just rewrote the problem. Sure did. And then you write equals, you get a point for linking these two things together. So then we're going to write limit x goes to 1. And now finally, we get to actually do the math of taking the derivatives. So the derivative, and you do them separately. The derivative of just this numerator is 2x minus 4. And the derivative of the denominator is 2x plus 3. And then you plug in 1 and you get your answer. So if you plug in 1, that's going to give you negative 2 over 5. So negative 2/5 is your answer. The way this typically works is it's worth 3 points. It's 1 point for all of this, the justifying using the rules, showing that these both come to 0 and writing this. It's a point for all that. It's a point for linking these two things together, which is using the rule. And then it's a point for the answer is typically how it goes. So I know that is a lot to have to write, but it's not necessarily hard. It's just very redundant. Anyway, for the rest of these, I won't make you do that. But on the free response, that's how you have to put it. So for this one, if you plug in 0, e to the 0 is 1. 1 minus 1 is 0. And then in the denominator, you're going to get 0. So you get 0 over 0. You want to check that because, like, if it obviously they're all going to come out that way on this paper because I'm teaching the lesson on L'Hopital's rule. But if it comes out to like 4 over 0, you can't use this rule. Again, it's only for these two forms. But this one does come out to 0 over 0. So we're going to link it together. Limit x goes to 0. And we're going to take the derivatives. So this is a chain rule. E is itself, e to the 5x, and then you chain on the derivative of 5x, which is 5. I'm just going to write it out front. It's not a power rule. You're not bringing the 5 down like a power rule. It's a chain rule. I just write it out front because it's easier. 1 is a constant, so that's gone. Derivative of x is 1. And now we're going to plug in 0. So e to the 0 power is 1. 1 times 5 is 5. 5 is our answer. All right, for this one, if you plug in 0, you're going to get square root of 25, which is 5. 5 minus 5 is 0 over 0. So 0 over 0 means we're allowed to use the rule. Derivative of square root is 1 over 2 square root. Again, you would do well to just memorize that one. When you have a square root, it's 1 over 2 square root. Now, technically, there's a chain rule in there as well. You would chain on the derivative of x plus 25, the inside, like the guts of it. But the derivative of x plus 25 is just 1. So I guess you could write times 1 if you wanted to. But yeah, just be 1. 5 is a constant, that's gone. Over derivative of just x is 1. This is why this rule works, is because when you take a derivative, you go down a degree. And so you end up with a lot of 1s and like the whole problem goes away. So now we're going to plug in 0. Square root of 25 is 5. 5 times 2 is 10. So 1/10 is our answer. All right, for this one, ln looks like this. It has a vertical asymptote at 0. As x goes to infinity, it's going to keep going up. So in this one, we get infinity over infinity. So we are allowed to use the rule. We're going to do derivative of ln, which is 1 over x. And then derivative of just x is 1. You can kind of ignore that 1. Sort of pretend that's not there. So you can't plug in infinity, but think about like this becoming a larger and larger and larger and larger number. You end up with like 1 trillionth, which is essentially 0. It's going to level off at 0. The other thing you can do is think about what the graph of 1 over x looks like. It looks like that sort of hourglass thing. The rational graph, as you go out towards infinity, you have that horizontal asymptote at 0. So, however you want to think of that. Now, L'Hopital's rule only works if you have a fraction. You have to have 0 over 0 or infinity over infinity. This one does not have a fraction, so I'm going to have to start out by rewriting it so that I do have a fraction. Negative exponent means that can come back down to the denominator. So it is going to look like that. And you get infinity over infinity for this limit. So we're going to take the derivatives. Derivative of x is just 1. Derivative of e to the x is e to the x. And then if you think about x going to a bigger and bigger and bigger, you can't plug in infinity, but think about this being like the largest number possible. Again, you end up with like 1 gazillionth, which is essentially nothing. So that is your L'Hopital's rule. You have to check that you get one of these forms. Only works for these. And if it's on the free response, you have to do the numerator and denominator separately. Write that they're both differentiable, and then link them together, link these two things together, taking the derivatives, and then you can plug in your number. So it, once again, is one of those things where the math is actually very, very simple, and all the writing and notation that you have to do is where it gets complicated. All right, on the back. Oh, I left a bunch of space here so we can write out our definitions of a derivative. So I am going to write out the first one, which if you recall looks like that. That gives you f prime of x. That's just the derivative in general. And then this one is the derivative at a specific point c. So like c would be a number in this case. So usually at some point in unit 3, I get asked, why on earth did we have to know these in the first place if we have all these rules to get derivatives? When are we ever going to need that? Well, this is how it shows up on the AP exam. Is when you see something like this, you do not want to do that as a limit. That's super complicated. Instead, what you want to do is recognize that that follows one of these two patterns. In this case, this one has the h in it. It's going to follow this pattern. And so what you want to do instead is write the function, take the derivative. You're recognizing that this means derivative, and then plug in the number that you're being asked to plug in, which in this case is not 0, it is 5. You have to look at it. It's not going to be 0. They wouldn't ask you to do 0. That wouldn't make any sense. Well, I mean, as I say that, I guess they could, but likely it's not going to be 0. It's going to be like some other number. So when you look at this, you're just finding the pattern. And this is a thing, it's very difficult to teach patterns. You kind of just need to do a bunch of them until you start to see it. I can't like force you to see it, but this one is 2x cubed. So you can see it's 2 times something cubed, and then this is 2 times the number you're plugging in cubed. That's the pattern that we have. Again, wait until I do a bunch of them and you'll start to see it. Derivative of 2x cubed is 6x squared. And then if you plug in 5 squared is 25, times 6 is 150, and that's your answer. So they usually throw at least one of these on the multiple choice on the exam. So when you see it, I mean, like, that's panic inducing, right? You're like, what on earth is going on? Instead of h on this one, they called it delta x. Sometimes they do that instead of h. If it bothers you, scribble out all the delta x's and call them h. All right, but again, what we're going to do is we're going to decide what the function is, take the derivative, plug in the number. Oh, I forgot my prime mark on this one. I'm so sorry. F prime of 5. And then in this case, we're going to plug in 3. So the function for this one is 4x cubed. It's 4 and then like something being cubed. Derivative of that is 12x squared. And if we plug in 3 squared is 9. 9 times 12 is 108. All right, I might not do every single one on here because after you do a bunch of them, it kind of just gets really redundant. So this one, the function is going to be 5x cubed plus 8x. What they did for this one, see how it's just minus 56? For this one, if they had done 5 cubed and then times 2, 5 cubed is 125, double that is 250. They could have just written minus 250. It's just minus some number. That's this part right here. So I'm not looking at that. It's 5x cubed plus 8x. This subtraction part is this part of the pattern. We kind of don't need that. You really just need the first part. So that derivative is 15x squared plus 8. And then the number that we're going to plug in is 2. So 2 squared is 4, times 15 would be 60, so 68. All right, for this one, our function is 5x squared. The derivative of that would be 10x, and then we're plugging in 2. So your answer is 20. Let me look through. I don't think we're going to do like every single one of these. Let me do this one because this is going to be the other pattern. It's going to be this one right here. See how its limit is x goes to c? See how we're not approaching 0? You're actually approaching another number there. So that's the other form. That's the form of your derivative that's at a specific number. The nice thing about that one is it just starts with the function. It's just the function. So when this is approaching 3, this first part just is the function. Like our function is just x cubed plus x. Again, that minus 30, that's this part, the minus f of c. You don't really need that. You really just need the first part. So our derivative of that is 3x squared plus 1. Again, this is x to the first. It's 1x to the 1. So power rule gives you a 1 there. And then we are going to plug in 3 for this one. Again, when you're using that other form where it's at a specific number, you can just go ahead and plug in, like 3 is the number that we're approaching there. So 3 squared is 9, times 3 is 27, plus 1 is 28. All right, and then maybe I'll do the trig one down here. So your function is sine of x. Your derivative of sine is cosine. And then the number that you're plugging in is pi over 2. So on your unit circle, pi over 2 is up at the top. Here, I'll draw you a picture. It's going to look like this. Cosine is the x part of the point, which is 0. So 0 is your answer to that. So again, the reason you have to know these formats, even though we have all of these derivative rules, is this is how it shows up on the AP exam. So when you see a limit that looks absolutely horrible, don't do it as a limit. Recognize it's a derivative pattern. It's one of these. And then just take the derivative, which is going to end up being really simple, and then just plug in the number that you're being asked to plug in. And again, I moved the paper really quick, so that's what the last one looked like.